Everybody say hi, Molly.
Hi, Molly.
They're all excited this morning. It's Friday, right? Kind of. Okay. It's Thursday actually, but it's kind of like Friday. Okay. So section 4.4. I've kind of prefaced this already, but for Molly, this is counting, and it's not like the counting on your fingers counting. This is counting the number of ways. You guys will see that. Write this at the top of your paper. They will ask for the number of ways or how many ways something will happen. Okay. How many ways can I choose 3 kittens out of a litter of 10? How many ways can I choose a president, vice president, secretary out of a group of 15 people? We're doing those guys today. That's what we're doing. This is counting.
Are we doing the whole
Okay.
notes today?
We're doing half of them.
Okay.
Yes,
Thanks.
correct. All right, counting.
Thanks, Miss.
You're so welcome. You're so
I
welcome.
appreciate it on this fine.
You're so welcome. All right, here we go. Number one, we have not gotten into permutation combination yet, okay? So don't be thinking that yet. This is just the multiplication counting rule. And I call that, in my other math classes, they call it the fundamental counting principle. Okay? Is it PAL or PEL? I think it's PAL if it's a noun. PAL if it's a noun,
No,
right?
Pal is Mr. Moore.
Yeah.
Yeah.
Principal
Pal is Mr. Moore, yeah.
What? A principal is, yeah.
Is a pal.
So it should be LE?
Mr. Moore's my pal.
It should be LE? Okay. Principal, like that?
Really, but
Principal?
right.
Whatever. Okay.
MJ's right.
Yeah. I know. Fundamental counting principle. There it is. Okay. Now, this is the example where it has like you have 3 shirts and 4 pants and 6 pairs of shoes, let's say, because if you just do 6 shoes, then it's kind of confusing. And then they say, how many outfits? You multiply them all together, right? 3 times 4 is 12 times 6. Anybody know?
32.
72. He did it in his head.
No, don't.
He didn't do it in his head. 72 outfits. Okay, now, the examples, though, that they will do are not quite so obvious, like the outfits example. Like, they will do this one, multiplication counting rule, and they're guessing a 4-digit passcode. So this is the first example. 4-digit passcode. Okay, when you see passcode, here's what I would highly suggest you do. 1, 2, 3, 4. Okay, and then we'll write in those boxes what numbers numbers or characters, maybe it's a letter, that we are allowed to have. Okay, make the 4 blanks and then you can see what's going on. Okay, those of you who are doing homework assignments, like whenever, get out a piece of scratch paper so you can write stuff down. I can't do it without writing something down. You do it by writing something down. It's super helpful. Okay, get out some scratch paper. All right, so these are the specifications of our 4-digit passcode. Each digit can be 0 through 9. How many numbers is that?
10.
If we can count 0, that's 10 numbers. That is the total number of numbers I could have, 10 numbers. And then we have to decide, can we repeat those numbers? What is the total number of different possible outcomes given that all of the guesses have the same chance of being correct? What is the probability of guessing the correct passcode for the first attempt? Okay, they don't say that we can't repeat, so we're assuming that we can repeat numbers, right? So how many numbers could be in this spot? 10. What's our number going to be?
Big number 10.
What's our number going to be? Pick a number. 1. Okay, this number is a 1. How many numbers could be in the second spot? 10. What's in the number?
4.
This is 4. Okay, how many numbers could be in the third spot? 10. Pick the number.
9.
6.
Next one.
Sorry, I don't know who said 6. I just heard 6 first. 10 could be in the last spot, and then we have 9. 1, 4, 6, 9. That is a code, right? How many total possible codes are there? 10 times 10 times 10 times 10. Don't use a calculator. It is 1 with 4 zeros, right? There's 4 10s, so 1 with 4 0. There are 10,000 codes. So if I guess randomly, what are the chances of me guessing that code exactly correct? 1 out of 10,000. Right? That's the chances. So there are 10,000 codes. I have a 1 in 10,000 chance of guessing it correctly. So if I guess 1 code per day, it's going to take me about 3 years to guess the code.
3 years.
Because there's 365 days in a year. So it'll take me about 3 years to guess all of them, right? If I hit the code on the first couple days, that'd be real great, right? Yeah. So anyway, don't listen to us.
3 years and 365 days.
Yeah, if there's
Just one every day.
no, it
It
would
would be
take
like-
like 30 years.
Yeah.
I'm thinking 1,000, 30 years.
Yeah.
Woo! Thanks, Maddie. Thanks, Maddie, for catching me. All right, factorial rule. Here's another one that's under the fundamental counting principle, but it's a little bit different. Factorial rule is used to find the total number of ways different items can be arranged. So here's my example. We have, let's say, how many people are in a batting order? 9? 9 people? 9-person batting order.
How do you know that, Caleb? You said it.
9-person batting order, okay? And I have those 9 people, and I'm choosing all 9 of them to be in the batting order, okay? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I'm going to choose the order in which they go, right? The order in which they go. So how many people could be chosen first as the first batter? 9. Now that one person has been chosen. So how many people could be chosen for the second batting order? 8, right? And then 7 people could be chosen. 6, 5, 4, 3, 2, 1. And we multiply all those together. But before you start doing that, that is the same thing as 9 factorial, okay? You guys have a button on your calculator that is a factorial button, and you need to locate it. It's an exclamation point, okay? So some of you have done this in algebra. Let me know if you can't find it on your calculator, and we'll find it now.
I can't find it.
You can't find it, okay? If you're a,
It's the
you know
period.
what's that?
It's the dot.
It's the math button.
Decimal.
Then you go to the math button.
I don't have one right now.
You have one right
Oh, sorry, your controllers.
Hey, I need.
Don't listen to me.
So 9,
It's
math,
probably the math.
and then we're
What
gonna go over
number
to
is math?
PRV,
Okay,
which
so
is
it's
where
the
everything.
math.
That was the
So
fourth
NPR
one.
and CR, those are all
Oh,
here.
prom.
Got it.
I got
Get
it.
this one,
You have one, you just have one.
I found it.
Okay, under the PRV. Oh, so you're gonna hit 9 first, and you're gonna go to PRV, and we're gonna use these two next. So just remember that it's on the PRV button. You want that factorial, so you go down and hit enter, and then hit enter.
I
So
love
9 factorial is that.
I
You don't
love
have to
it.
type it all in, right? Okay. Anybody else not know where it's at? Yes. Yes, I'm coming.
Yes.
That's your own.
That's
I
your
would pay, I would pay money.
Right.
If he goes bald, you go
Okay,
bald.
so 9 and
I can't either. My girlfriend would kill me. So
Same, I would also lose my relationship.
I wanted to shave my head during football. She's like, you
Oh, really?
If
I
I
mean,
put you in
I'll take it up on the back. I'll shave my head. I really
I don't think she's serious, but she would be very angry. So would everybody.
Probably wouldn't.
I wouldn't
ask
do
if I
that.
could shave it. I wouldn't shave it.
I'll just do one down the middle.
Like,
How much money to do that, Caleb?
No, I would not.
Anybody else
I
not find
feel
it?
like I'm freaking out for like.
Did you find it?
Okay,
Okay, what was that number? 362 880. What does this number tell me?
how many chance?
That's how many different batting orders I could have. Okay? Now, did you know, those of you who have had permutations, combinations before, this is exactly the same as 9P9, which we'll get to. We don't know what P stands for yet, but some of you do. P stands for order matters, right? Okay? So we have 9 people. This is the total number of people that we have, and we are choosing all 9 of them, right? Okay? So we have 9 people. We're choosing all 9 of them, but we're doing them in different orders. We're putting them in different orders for the batting order. That is the same thing. 9 factorial is the same thing as 9P9. So if you would rather enter it in as a permutation, you can do that as well. But those are the same thing, okay? We'll get to that here in a little bit. 9P9, that's the same thing, okay? Choosing. You're choosing all 9 of them to participate in the batting order, right? You have 9 people, and you're using all 9 of them to fill your batting order. It's not like you have 12 players and you're only choosing 9 to fill the batting order. You have 9 players, you're choosing all 9 of them. Yes, yes. Good question. Okay, moving on. Whoop, wait. Travel itinerary is the next one. Example 2. Let's go down here. A statistics researcher must personally visit the presidents of Gallup, Nielsen, Harris Pew, and Zogby polling companies. The first thing I'm going to do is, how many is that? How many places are we going to visit? 5. 1, 2, 3, 4, 5. There are 5 places. And since that's a total number, I usually represent that as n, right? N is 5. This is the total number of places that I am visiting. Okay, how many different travel itineraries are possible? And the key word there is different. So when they say different, let's say I choose to go to this company first and this company second. Is that the same thing as going to this company first and this company second? No, because they're saying different. Even though I'm going to both of them, it's saying different, and those two are different. So we do count them individually, okay? So how many different itineraries are possible? I have 5 different places that I can go to. 1, 2, 3, 4, 5, right? I kind of like write this like the passcode. How many places can I choose to visit first? 5. How many places can I visit next? 4, 3, 2, 1. So you can enter that in as 5 factorial, or you can go 5p5, right? And that is how many? 720? 120. 120? 6 factorial, 720. I can't remember. 120. 120 is 5 factorial. There's 120 different combinations of those cities together that I could do, right? 120 different itineraries that I can choose from. If we only have 5 cities or 5 companies to go to, there's that many choices. That's crazy, okay? If the itinerary is randomly selected, what is the probability that the presidents are visited in order from youngest to oldest? 1 out of 120. They're trying to confuse you. There's only one way to order them from youngest to oldest. Only one way. Only one way out of 120. So 1 out of 120 is the order from youngest to oldest. Don't get bogged down by the whole youngest to oldest thing. There's only one way of arranging them youngest to oldest. Okay? 1 out of 120. Make sense? Happy with that? Okay, now they're going to talk about permutations versus combinations, okay? When you're doing a permutation combination, I am not going to make you memorize the formula. I didn't make you do it in Algebra 2 or geometry. I'm not going to make you memorize the formula. Like the actual formula for a permutation is this thing. I'm not going to make you memorize that. I don't care, okay? We're going to just strictly talk about what it means to be a permutation versus a combination. So put those down below here. Permutation versus combination. Okay, permutation, combination. Okay, in each one of these, you will have 2 numbers. You will have an N and you will have an R. Okay, and N is the total number, and R is the number of things that I am choosing. Okay, up above, when we had a batting order of 9, that was a total, and we were choosing 9. So those were both the same number. N and R were both 9, right? But we have N and we have R, and we have the total, and they have the number choosing, okay? All right, permutation, you're going to enter this into your calculator as NPR. Combination, you're going to enter it in as NCR. NPR versus NCR, okay? And how do you remember the difference between the two? Permutation, order matters. Okay, and the order in which I choose them matters. So we want order. Combination, order does not matter. Okay, let me give you an example of how that works. Order doesn't matter, order does matter. Okay, there are 17 of you in here, including Molly. And I am going to choose 3 of you to get first, second, third place out of some contest that we're going to do, okay? So I'm going to choose India as first place. I'm going to choose Ashton as second place, and I'm going to choose Lily as third place, right? Is that the same as me choosing Ashton as first place, Lily as second place, and India as third place? Of course not, because India's like, I was first, and now I'm third. This is crap, right? So the order does matter, okay? And the way that I remember order does matter is order starts with a P, and what else starts with a P? Not order starts with a P. Permutation starts with a P, but what else starts with a P?
Not order.
Do you guys remember this? President. When you're doing president, vice president, secretary. Does president, vice, or does president, secretary, does order matter when you're doing that?
Yeah.
Yes, so president and P, that's how I remember it's a permutation. Order matters with a P, right? Order matters with a P, okay. Combination starts with the letter C, and so does the word committee. So does the word committee. So if I have this group of 17, and now instead of choosing first, second, third place, I'm choosing Lily Ashton, India, to be on a committee of some sort. How I call your name out, if I call Lily Ashton, India versus Ashton, India, Lily, it doesn't matter what order I say your names in, because you're all going to be on the same committee. You have the same job, okay? So I'm going to put over here, same job. If they have the same thing, same job, then the order doesn't matter, and it's a combination, right? combination committee. P is permutation for president. Those are the same letter. That's how I remember the difference between the two. Yeah? That's it. Okay? Should we do an example of that before we move on? Yeah? Just one really quick example. Okay? So, example. Let's just write down the example that we had. So, I'm just gonna say, let's say 10 students instead. 10 students choose vice president, secretary. How many ways can I do that? I have 10 students choosing president, vice president, secretary. Okay? Versus the example over here, I have 10 students. And I want 3, 4, what do we want them to do? Trash pickup. He was so prompt with his answer. Trash. Okay, 3 students for trash pickup. All right, so order matters when I'm choosing president, vice president, secretary versus it doesn't matter when I'm choosing 3 people for trash pickup. Okay, so this would be, how would you enter this into your calculator just so we can practice? This would be 10p3. Now, check it out. This is totally idiot proof for a reason. Are you ready? If you try to enter this in as 3p10, it will not give you an answer in your calculator. That's very nice because then it won't give you a false answer. You will get 0 or it will say error. You cannot have it. So 10p3 is some number. How many ways can you choose 3 when order does matter?
How do you put that in?
Okay, so you start with the number 10. You have to enter 10 in first, and kind of in the same location as the P button or the factorial button was. You find the P button and then you enter 3 in. Everybody practice that. Do 10p3 on your calculator. In the same area. 720, is it 720? Okay. Did everybody find their P button? Yeah? Jackson, did you find your P button? Okay. Erica, did you find your P button? Indy, did you find your P button? Okay. All right, 10p3. Now, hold on. Before we do C, is this going to be a bigger number or a smaller number?
Smaller.
Why smaller? Because the order doesn't matter, so we're deleting out the repeats, right? We're deleting out the number of repetitions that we have. So 10C3, if you're using the same numbers, the combination will always be smaller, and this is 120? Yeah, 120. 120 versus 720, make sense? Okay, combination, kind of in the same area on your calculator as the P button. Yeah? Good. Okay. All right, so let's do example 3 and then we'll stop. So we've already talked about this permutation rule. I'm not gonna beat the dead horse because we've already gone over this. So I'm gonna skip over this part. We're gonna go straight to example 3, and here we go. Example 3, permutations rule. In a horse race, a trifecta bet is won by correctly selecting the horse that finishes first, second, and third place. Does the order matter when you're selecting first, second, and third place? Yes. And you must select them in that order, so that tells me permutation, okay? Permutation, just because of in the correct order. The 140th running of the Kentucky Derby had a field of 19 horses. So what is 19?
That's our total.
That's your total. I'm going to label as N. What is R?
R is 3.
3, because we're choosing 3 of them for first, second, third place. How many different trifecta bets are possible?
5,800.
So you did 19P3, and it was 5,000 what?
5814.
5814, 5,814. That is a lot of combinations. People don't realize that out of 19, you have 5,000, almost 6,000 different ways. But they bet anyway. They have a 1 in 6,000 chance of getting it right if they guess randomly. Now, going off of what horses have run in the past and whatever, that gives you a little bit higher of a chance, right, of getting it correct based on given information. But if you just randomly select 3 out of the 19 in a certain order, you have a 1 out of 5,000, almost 1 out of 6,000 chance of getting it right, okay? So there's that. All right. If a bettor randomly selects 3 people, that's what I'm just telling you. A bettor randomly selects 3 of those horses. What is the probability of winning?
1 out of 5,000.
1 out of 5814. That is the probability if guessing. Probability if guess. If I just pick my 3 favorite numbers and put them in there, okay? Now, Do all of the different possible trifecta bets have the same chance of winning? Ignore dead heats in which the horses tie for a win. Do all the different possible trifecta bets have the same chance of winning? Yes. 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 Yeah, they should.
Guess randomly.
Yep. If you guess randomly, they all have an equal chance of winning. Yep. Yep. Yep.
Is that it?
Right. Yep.
Can you go over time?
That's all I think I have for you. We'll stop there. Okay? All right. Use this time to work on some stuff. I'm going to go finish checking some trig papers.
Can you help